Hi, welcome to this quick review of Newton's second law, F equals ma, force equals mass times acceleration. I'm glad you've joined us. We're going to cover them in the basics and do a practice problem or two. So welcome aboard. Hi, so let's get started. Newton's second law, we're talking about this on Friday, December 13th, 2013. Let's start with the definition from the book, page 20. Let me read it to you. The acceleration of an object is directly proportional to the unbalanced force acting on it and is inversely proportional to the object's mass. The direction of the acceleration is the same as the direction of the unbalanced force. Let's unpack this definition piece by piece. When we're talking about acceleration, we're talking about a change in an object's motion. In particular, acceleration is a change in velocity, the change in speed, divided by the change in time. An object, we're talking about something. A system can be broken down into pieces, components. We're talking about some thing with forces acting on it. Separate from other things or connected to other things. It's an abstraction where it's just a thing. It's a shoe, it's a book, it's a person, it's a bicycle, an object. Directly proportional means that as force changes, acceleration changes in the same direction. That's directly proportional. The weight of somebody is directly proportional to their size. The bigger a person is, the bigger their weight. Unbalanced force. A tug of war has a team pulling against another team. If one team starts to win, the other team gets pulled towards the team that's winning. The teams are balanced. The little mark in the center of the tug of war isn't moving. A team that's winning has the mark that's moving. A team that's winning is an unbalanced force against the other team. Inversely proportional. Inversely proportional means that something goes up, another thing goes down. Think of a fraction. You got the numerator, you got the denominator. If the numerator stays the same, if the denominator gets bigger, the fraction gets smaller. The fraction gets smaller as the denominator gets bigger. 1 over 2 is bigger than 1 over 4, which is bigger than 1 over 8, which is bigger than 1 over 16, etc. Mass. The bigger the mass of an object is, the lower the acceleration. That's inversely proportional. As mass goes up, acceleration goes down. This is related to inertia, Newton's first law, Galileo's principle of inertia. Inertia is an object's resistance to motion. The direction of the acceleration. Force is a vector, has direction, has magnitude. The direction of an unbalanced force determines the direction of the acceleration. If an unbalanced force is pushing me towards the right, then my acceleration will be to the right. If an unbalanced force is pushing me up, my acceleration is up. If an unbalanced force is pushing me down, my acceleration is down. Direction of the unbalanced force, same as direction of the acceleration. Unbalanced force, acceleration. Newton's second law can be summarized as an equation. F equals ma. Let's take a look at each of the pieces of the equation. F stands for a force. It's a push or pull force. Equals M stands for mass. It's how much stuff you've got. Is it a big thing? Is it a small thing? It's how much inertia you have. A stands for acceleration. It's a change in speed. A is just the motion. It's what happens to something because of a force. Let's put it all together and talk about the units in the equation F equals ma. First, F is the force. It's measured in newtons. We write big N. In this equation, the units on the left are equal to the units on the right. We call the left side newtons, call the right side some other things. In particular, M is the mass. It's measured in kilograms. We write kg. A is the acceleration. It's measured in meters per second squared, m over s squared, meters per second per second. So altogether, a newton on the left is equal to a kilogram times a meter per second squared. Now let's look at some applications of Newton's second law, the equation F equals ma. Basically 3 types of problems. First, if I give you the mass and the acceleration, you tell me the force. If I give you the force and the acceleration, you can tell me the mass. And if I tell you the force and the mass, you can give me the acceleration. So given 3 quantities, I have to give you 2. You can give me the other one. Let's do the first one. What's the force if I give you the mass and the acceleration? The fastest time for a car from 0 to 60, according to supercars.org, is 2.4 seconds. It's an average acceleration of 11.2 meters per second squared. Pretty fast. If the mass of the car is 2,035 kilograms, what force does the engine provide? F equals ma. Force equals mass times acceleration. In this case, mass is 2,035 kilograms. Acceleration 11.2 meters per second squared. Multiply those together, you get 22,792 newtons. Pretty large. This car has a 16-cylinder engine. Second type of problem. What's the mass given the force and acceleration? I like to draw this picture, a little diagram, F over ma. If I'm asking you what the mass is, you cover up the m. It leaves F over a. F divided by a equals mass. A tennis ball is hit with a force of 6 newtons. Pow! Has an acceleration of 100 meters per second squared. What's the mass of the tennis ball? I have force. I have acceleration. Mass is force divided by acceleration. M equals 6 newtons divided by 100 meters per second squared. You can write the fraction 2 different ways. Mass equals 0.06 kilograms. Third type of problem. What's the acceleration given a force and a mass? Again, I like to use the diagram. If I'm asking you what the acceleration is, cover up acceleration. What's left? F over m, force divided by mass. So the mass of a book is 2.5. What's the acceleration? Okay, so the mass of a book is 2.5 kilograms. I push on it with a force of 9 newtons. What's the acceleration of the book? I know what the mass is. I know what the force is. Acceleration of the book is force divided by mass. Force is 9 newtons divided by mass, 2.5 kilograms. 9 divided by 2.5. Acceleration, 3.6 meters per second squared. Those are the 3 types of problems you can get. So here's the summary. We talked about what Newton's second law is. Unbalanced force causes an acceleration. The direction of the acceleration is the direction of the unbalanced force. No unbalanced force, no acceleration. Object stays at rest. We talked about the units of force, the units of mass, the units of acceleration. We talked about the type of problems or applications that you can solve with F equals ma. So, thank you for watching. That was Newton's second law.